Hi, everyone. Welcome. We'll give it a few seconds to just let everybody log in. But welcome to today's webcast. Today, we're going to be doing why is VCF the best platform to run VMs and containers? This is actually a part 2 webcast. We did do part 1 last week. So part 1 was kind of an overview, and today we'll be doing more of a deep dive into everything. So before we begin, I know a lot of you were here last time, but I just want to go over a couple housekeeping things really quick. First, we will be recording the webinar and it will be available to you on demand. If you did miss part 1, I just put the video in the chat. You can watch that later and still stay on to today if you want to kind of get some of the deep dive and then maybe go back. But the second one will also be recorded and we'll put that up on the VMUG website as well. Second, we are going to have some Q&A at the end of today's webinar. Sometimes the chat gets a little overwhelming, so if you just want to put any of your questions in the Q&A box, that will be the easiest way for our presenters to find your questions. And then third, there is going to be a short survey at the end of today's presentation that'll pop up once you close the webinar. So just take a minute, let us know what you thought about today's session and also what you might like to see in the future. We do take those thoughts into consideration as we're scheduling webcasts for future days. So let's go ahead and get started. Without further ado, I will hand things over to Michael Roy at Broadcom's VCF team.
All right. Thank you, Julianne. Really appreciate it. Thanks, everybody, for joining us once again today. Part 2 in this exciting series. Again, I'm Michael Roy. I'm your guide into the VCF division, aka VMware by Broadcom. We're here with another installment of our ongoing series of webcasts, continuing our mission to help the community of admins, i.e. folks like yourself, in every way that we can, be successful with VCF and all the new VMware technology coming out of Broadcom. So last week, we started a discussion on containers and the platform who loves them. Specifically, of course, I'm talking about VCF and Kubernetes. Last session, we took a look at more a high-level look, really, at what the VCF platform, now with Kubernetes dial tone baked into it, can do for you, how to get operational with it, and sort of what that value can look like at the end of the, the exercise there. Going through the motions of standing everything up. So we spent a little bit of time at the end of that with a demo from Katerina, one of our crack technical product marketers here at Broadcom. And today, we're going to dive in even further. So we love demos. We love getting into the nitty gritty, the deep, the hands-on keyboard actual stuff. And we've got no one better suited for that than Katerina on our team to come here and help share the story there. So we have the whole session to go deep with more detail, more demo, and all, again, in service of making folks like yourself as successful as we can within the new VMware Cloud Foundation platform. So again, like Julianne mentioned, drop your questions in the Q&A. We'll try to answer them either as we go or we'll bucket them up at the end. Kind of depends on the question. If Katerina can address it, if she notices it while we're doing the presentation, then she'll be able to address it in real time. Otherwise, we got some time that we're earmarking at the end of it to kind of address questions and whatnot. So I'll be keeping an eye on the chat and on the questions as well. So like I said, I'll try to answer these things as we can if it's something that I can. Otherwise, we'll bring it all up at the end. So without further ado, I want to invite Katerina back on up. Come on, take us through it.
Thank you very much. Thanks. Welcome, everyone, to this webinar, part 2, as was mentioned. If you have joined us last week, we have tried to tell you why we believe VCF is the best platform to run containers and VMs. And what I want to do today is I want to peel the layers a little bit and go a little bit deeper, explain how we're doing things, how we implement things, and also show you demos, because if you've ever been to any of my presentations, that's what I like to do. I like to show you the real stuff. So I will start with some slides, but don't worry. I think I have like 5 slides just to set up the scene, get us all at the same level. Also, for those maybe who did not see part 1, make sure that you can go and check that afterwards, but just to get us all on the same page before we go into the demos. So my name is Katerina Brookfield. I'm part of the technical marketing team here at the VCF division. And this theme or topic or anything to do with Kubernetes in VCF is sort of my baby. So I really like talking about it. So I'll make sure that I give you enough information, but also that it doesn't go too long because we don't want to spend too much time on it. Right. So what I wanted to do initially is to kind of tie this to part one. And I'm not going to show all of the slides that we have done there, but there was one slide that I think we've used to kind of set up the scene. And it's really important to understand in this context. So when we talk about VCF, our VMware Cloud Foundation, as the platform to run all of your workloads, there are a lot of parts that come into play here. Not only are we integrating our best of class compute and storage and networking, but we are layering on top additional functionality with our automation and our operations, but also with this interface that we have created specifically for consumers. And that's the interface that gives you this ability to do all of this modern stuff that we're here to talk about, like deploying Kubernetes clusters and deploying VMs and all the interesting stuff. But that's nice when you see it on a slide like this. But what I want to do is I want to guide you quickly through the layers of how we are actually implementing this, why we have chosen to do it this way, and what we're trying to achieve here. The one thing that I would like to point out on this slide, though, is, as you will see, we are trying to somehow target two personas. Now, don't take this as a given, because depending on your organization, the responsibilities in your teams may be slightly different. But when we talk about sort of cloud experience and a private cloud, you usually have two kind of personas. On one side, you do have, cloud admins, VI admins, the administrators who are responsible for the infrastructure. And usually on the other hand, you have the consumer. So this can be the DevOps team or the platform engineers or anyone who would be interested in that kind of self-service experience. And that's exactly what we are trying to build. So we have mentioned before that how we deliver this is with our embedded Kubernetes runtime and our embedded declarative API. So if we look into that, that's what we call our vSphere supervisor. So on the bottom of all of this goodness is this embedded declarative API called vSphere supervisor that allows us to create this cloud experience. Now, I think it's really important to understand what we mean by that, or how would you define that? Because if you talk about cloud experience, to me personally, it's mainly about two things. It's about having accessibility to all of these services that I can use, but also the other part is the consumption. As a user, I want to have everything available. I want everything to be easily consumable for me. And also I want to have a very consistent experience as I'm working with services, whether I'm deploying Kubernetes clusters or I'm deploying VMs, or I'm deploying anything else that I want to do on the platform. I want to be able to do it with unified methods. And that's why embedding a declarative API directly into VCF, we are able to use that as a single target for all of these operations. So whether I'm deploying VMs, Kubernetes clusters, but also any other infrastructure objects, like, for example, if I'm deploying load balancers, I want to do that on demand, so I can use the same API to target it. If I'm deploying anything on storage, like persistent volumes, I want to be able to use the same single API to target. And I can do that because, again, everything is provided by the single layer. So the also important point here to make is that this really provides also the abstraction layer for the consumer. So as a consumer in this world, I'm only interested in deploying my workloads, but I don't really need to know what's underneath, which vCenter am I going to, or which data store should I use? So this was really built with that self-service in mind and really trying to offer that infrastructure as a service cloud experience. But what is also very, very important here is that the reason why we have done this way is because it's extremely extensible. So we are able to introduce and add new services on top of the platform, but using, again, because it all lives in the same ecosystem, it's with a native integration. There's no third party of connecting things together. Everything is deployed together. So it's this ecosystem that can grow to your needs and tailor exactly to what you need. But what it also means for us, that we can use the same ecosystem to introduce new services on top of VCF. So if you actually look at some of the advanced services that we are offering, like, for example, private AI, that is what we are doing. We are utilizing this ecosystem of this vSphere supervisor to deliver a solution like that. So that's the kind of overview and a middle step of, okay, so we know VCF, one platform, we're trying to target, cloud experience. Now we know a little bit more. So, okay, we have this supervisor layer, and that gives us all of these services that we can consume. So these supervisor services. And the last step where I want to go is just look at how that works in detail. And the first thing I want to highlight here is that I've mentioned this before, that the vSphere supervisor is a declarative API. So what does that mean? It's a Kubernetes-based declarative API, which basically allows me as a consumer define what I want to achieve without having to worry about how it's done. Because the whole beauty of Kubernetes is that we only define our desired state. So the end state, my main goal, that's what I define. And everything else is done by the platform for us. So in order to illustrate this really simply, if, for example, I would be deploying a Kubernetes cluster with our vSphere Kubernetes service, there's really two main things that I need. I need to first define what I'm deploying. So I need to define some sort of a cluster manifest to define how my cluster should look like. So if you're deploying a Kubernetes cluster, you would have a certain control plane. So you can define like how many nodes you want to have there, replicas, same for the worker node. So the definition of how that cluster should look like. So in this manifest, which is YAML-based, all I'm doing is saying, this is my desired state. This is where I want to get. This is the end goal. And then I let the platform figure out how to get there. So in order for the platform to do that, it needs to know how to do that. So because this is Kubernetes-based, in Kubernetes, to simplify it, there are two main things that we kind of need to be able to service this request. So first of all, we need some sort of a resource definition. So we need to know that, oh, if I'm asking for a cluster, what is a cluster? So we're defining our resources. And also, usually you will have some sort of controllers or operators that are running in the supervisor control plane. And basically, they're watching for the operations, what's happening. They're making sure that when the request comes in, they will go ahead and deploy everything that is required so they can manage the life cycle of that resource. And again, the beauty of this ecosystem is that this would work for any resource that you are deploying. So if we want to introduce a new service called X, all we have to do, we have to teach our supervisor control plane how to work with that resource. So in Kubernetes, you would create something like a custom resource definition to define what the resource should look like and what it should do. And then again, usually you would create some sort of an operator or a controller that would manage the lifecycle of the resource. And because that gets added to that declarative API, which is extended, it will be used then moving forward to manage all of these resources. And that's why the same principle applies when I'm deploying Kubernetes clusters, or I'm deploying virtual machines using VM service, or I'm adding any other functionality. For example, if I'm deploying additional supervisor services, like in this example, Harbor, which is my container registry. So if as a consumer, what I need is to place my container images in a private repository, I can go ahead and deploy something like Harbor onto the platform to make sure that we can have that privately. So I think the main idea here is that everything is repeatable, everything is extensible, and that what makes this really great platform, because we can make sure that not only we offer services out of the box, like for example, some of these that are introduced, but also we allow you as customers to bring in any new services that you would want to add to tailor and extend the platform exactly to fit your needs. And that's pretty much it for my slides. So what we will do now is we'll go through a couple of demos. And what I want to do is I want to start with the perspective of the cloud admin. So how would you set up this environment from beginning? What would be some main concepts that you need to do? And then later on, we can look at it from the perspective of the consumer. Because again, the main idea here is that we are enabling self-service consumption for our consumers while still staying within the guardrails and policies that are defined by the cloud admin. So let me stop sharing this and let's jump into the first demo. And as I mentioned, in this first one, what we will do is we will start with configuration of our supervisor, just so I can explain this a little bit more. So in here, we have an environment. It's very simple. It's my lab. But what you will see here, we have a simple vSphere cluster with 3 A6i hosts. And this is running cloud version. So this is running vSphere 8.3. In here, we're going to enable supervisor. Then we will very quickly go through the process. It's quite simple. It only has few steps. So what we will do in here is do just basic configuration. As you can see, 5 steps and we'll be finished. This is something you would do on a cluster once because you would only enable this. So think of this more as a part of your cluster configuration, same as when you are enabling DRS or configuring HA. So few selections we have to do here. I won't go into all of the variations and details to keep this demo simple. But what we will be able to do here is define what kind of networking stack we want to use. So in this demo, I will be using NSX with NSX Load Balancer and some other configuration options. Now, if we have already configured supervisor somewhere else, we can always export this configuration in a form of a JSON file and then simply import this. So this is also very useful if you are enabling supervisor in multiple locations, or maybe you are trying it out in a lab environment and you've had a working configuration, you can save it, export it, and reuse it later. All this will do is just pre-fill some of my fields, so we'll still go through them. So now I've selected NSX as my stack. Now I'm going to select the cluster where I want to enable this. I'm going to enable some simple storage policies. So all this is saying is basically which data store should be used for my object for storage placement. And now I need to do some basic networking configuration. We have 2 types of network in here. So there's management network, which is used by the control plane of the supervisor for management operations. And then we have our workload network for our workload. So I'll just define simple IP addresses in here, define my the scopes for my workload networks as well. And afterwards, I can just review this configuration and finish. And this will now go and configure my supervisor. And after a while, we will see that our supervisor is running. The next step that I need to do in order to enable this environment for someone to consume is create something that's called a vSphere namespace. So in my management, I will go ahead. I'll select the supervisor I have just deployed, and I will give it a name. Once we get in there, I will explain a little bit more. So when you think about vSphere namespaces, it's something that really shows that marriage of vSphere and Kubernetes, because we take something like a resource pool, but we layer on top Kubernetes capabilities that we need in this supervisor ecosystem. The idea of namespaces is to create this logical separation within your cluster, where you can maybe create namespaces for like various stages of your development, like testing, staging, prod, all of that, or maybe create namespaces per teams or any kind of separation you would like to do. And in each namespace, you can do certain configuration and apply policies. So for example, in here, I can assign permissions. So what I could do, I could assign my consumers specifically to a namespace. So they would only be given access to the workloads and the objects that are created within the namespace, not anywhere else. That's a very important point because this is a self-service offering. Then I can assign, again, as an admin, I can assign a storage policy to dictate which storage can be used in this environment. If I want to, I can also create some quotas and some limits for my capacity usage for my CPU, memory, and compute. And also, I can do some basic configuration for our Kubernetes service and for our VM service. So I will go into the details a little bit later, but just briefly here as a first configuration. For our Kubernetes service, we deliver our releases using a content library. As you will notice there, we have just enabled supervisor, and there's already a Kubernetes service content library that has been created for us automatically. So we automatically deploy that and assign it automatically to all of the namespaces that get created. And then for VM service, we need to do a little bit of configuration. First step is to define which VM classes can be used within this namespace. Now you can think of a VM class as that kind of t-shirt size configuration, as you would see in many other cloud providers as well. So this is what defines the hardware resources of the VM. So the CPU, the memory, the reservations, but you can also create custom ones if you want to attach any, for example, PCI devices like a GPU. So what I'm selecting here is I'm saying that my consumers who will work in the scope of this namespace will be able to deploy VMs with these sizes. So I'm just allowing that. And then there's a second part to the VM service. When I mentioned the Kubernetes releases, we do create the Kubernetes service content library by default on enablement. With VM images, it's slightly different. The reason is that you can very easily create your own VM images, but we also don't, at the moment, don't distribute any automatically. However, there are some POC images that you can download from our VM operator website. So that's what I'm going to do here, just to very quickly enable VM service as well. So I will just go ahead and create a new content library called VM images. I will just select the storage where this should be deployed. And once I have this content library, I can upload images into this. So just to enable this very quickly, as I mentioned, I can upload an image. And as you will see here, I'll just import an item. And it will be just the basic cloud image that I have downloaded previously. So I don't have to make any changes to it. I just simply download it and then upload it to the content library. Right. So for this, I have just downloaded my Ubuntu cloud image. So I will add it there. You can change the name if you want to. And import. Right. So now that we have a content library created, we must not forget to associate it with our namespace. So I'll just go to the namespace and I'll make sure that the content library is added. And now I have finished the configuration of the namespace. So my consumers, if I would give them permissions, could go ahead and deploy their object. Now, because I want to make their life easier, I'm going to deploy something else. And I have mentioned before this whole concept of supervisor services. So before I deploy the one thing, I want to spend a little bit of time on explaining these. So when it comes to supervisor services, you will notice that there are some that are marked as core services. And what this means is that these get enabled by default on enablement. So as you will see, by default, you will get our VM service, you will get our Kubernetes service, but also Velero for your backup purposes. So some of the services are deployed by default. And then what I can do, I can add additional services to my platform, again, depending on my needs. So for example, in my labs, as an example, I always deploy Harbor because I want to have a local private OCI image registry. In this example, what I will do is I will deploy something that we call a local consumption interface. And this is something we have introduced in update 3 and was by popular demand. It's a localized version of our cloud consumption interface that you can find in ARIA Automation. And we've enabled this localized version just to give you this kind of local experience if you are testing something and want to do something in this small scope of a single vCenter. So I have registered that service now, and all I have to do now is to install this. And again, as you will notice, because again, everything is managed by this declarative API that is Kubernetes based, you will see that also these services, what I have done is I have downloaded a service definition file, which was a YAML manifest. And now I'm deploying the service. And as you can see, this one particularly deploys a certain amount of pods that provide this functionality. And then we also saw that because this is actually a plugin for the vSphere client, it will deploy the plugin as well. So now I can go into my namespace and have this localized version of this consumption interface that I could use for my deployments. If I want to test something out as an admin, or again, I can now give access to my consumers to go deploy their workloads into the namespace. So I will just very quickly stop here and have a quick look if there's anything on this in the chat while I'm switching to the next demo. That seems okay. Right. So now I've done that kind of initial configuration that you would do. So the supervisor, keep in mind, is something you would enable once as a configuration. Then with namespaces, you would create those depending on your needs. So again, you can create multiple on the supervisor, divide it as you like, and define different policies and different kind of boundaries, and enable your consumers. And now we're going to have a look at the consumption part. So the first one I want to start with before we end with VKS, which is always the popular choice, is I want to show you VM service first. And there's a reason to that. Let me just quickly share this. So we'll start looking at how we can deploy virtual machines using the same API. So as you will see, we will start where we left off. So we are in our namespace, and we are on the resources tab because that's the user interface we have just deployed. And now I can go ahead and deploy a virtual machine. So I will just create a new virtual machine, and I will give it a name. Now, when it comes to the images, you can see that this is the image that we have uploaded to that content library that we have associated with this namespace. That's why I can see it in the list. I can now select the VM class that I want to assign to configure the hardware resources. So again, depending on what my admin would have configured in the namespace, that's what is available to me to choose from. I can do storage policies, and at the same time, I can do some advanced settings. So this is really important, and it ties back to the whole VCF as a platform story, because we are not just giving you simple runtime services or simple deployment of a VM or a Kubernetes cluster, but the true power is really shown when we integrate this with that underlying infrastructure as well. So for example, I am deploying a virtual machine, but I want to give it also some persistence for my data. So I will create an persistent volume. And all I will do here, again, because this is a declarative API, all I am saying is that, hey, I would like to have the space of 5 gigabytes because it's my lab and it's small. And it will go ahead and do that for me. So at this point, I'm just defining what my ideal state would be. The same applies to load balancers. So in Kubernetes, by default, everything is private. And what you want to do is you want to expose certain ports, certain services on your workloads using load balancers. There are multiple types, but just to keep this simple, in this VM that I'm deploying, I want to be able to SSH onto it. So what I will do is I will create a load balancer on demand, and I will just add port 22 to open that up. So I will be able to SSH onto this VM later. And another really, really important thing I want to mention here is that in our platform, all of these operations are done really securely. So you will see that there is no sharing of any passwords or any configuration of how to do this. Is the supervisor as the secure layer that is handling all of these requests. So if it needs to talk to, for example, VCF, it's the supervisor doing it. If it needs to talk to NSX, it's the supervisor doing it. The workloads never get the chance to reach anywhere. And once we get to Kubernetes clusters, I will put another layer on top of that. And the real beauty, again, of doing something like virtual machines with these kind of modernized principles as well, is that we can use other things. Like, for example, we are able to fully configure this virtual machine during its first boot. So what I'm doing in this example is I'm passing through configuration using Cloud Init during the first boot of the virtual machine. So I will not just install a blank virtual machine. I will do a configuration as well. In this example, because we are deploying a CLI VM that I use for everything in my labs, you will see that in my cloud config, what I'm doing is I'm defining new users, and then I'm running a set of commands to configure tools on this VM. So you will see that I'm installing kubectl and kubectl vSphere plugin, for example. I'm installing my vCenter certificates to be able to connect to my vCenter securely from this machine. And I'm also mounting the persistent volume that I have requested, that I'm still requesting in this deployment flow. And then I'm installing some other tools that I use on my CLI machines. So before I deploy this, you will notice that all of these resources have been defined as Kubernetes resources, and their YAML manifests have been automatically created for me. So as I mentioned on the slides, because this is a Kubernetes-based ecosystem, every resource has a definition, and the definition is stored in a YAML manifest. Now, you don't have to use the user interface. I could very simply create these YAML manifests and just use kubectl to talk to the API directly. But if you are new to this space, and even if you are not, let's be honest, nobody likes writing YAML because it's very specific and hard. So we are creating these for you automatically. So every single resource that we have requested here will be created. So we have our virtual machine. We have the secret that we are using to bootstrap the VM. So that's the configuration that we are passing through. So our cloud config. We also have the load balancer that we have requested. And if we would scroll down, we would also see the persistent volume. Now, what I can do here is I can download this if I would want to reuse this later. So maybe even if you just want to test something, I often do that as well, is I just do write in my configuration in my user interface and download the YAML manifest, even if I don't need to deploy it. So now I'm going to just deploy. And again, keep in mind, all we have said is we've defined this is my desired state, and the system is going off and deploying this for us. So after a while, we will see that this is powered on and it has an IP assigned. And in this interface, we can also look at all those other objects that we have requested. So for example, I have requested that extra persistent volume. So that has been created for me and it's bound. And also, if I look at the network service, I will see that the load balancer that I have requested has been created and has given me an IP address. So I will just take this IP address now. And because I've opened this on port 22, I can SSH onto this VM. So I am actually, as I'm going through this flow, I'm testing a few things, right? So when we went through that cloud init configuration, I have created a user called DevOps, so I have just tested that that works. I have installed kubectl and kubectl vSphere plugin. So by me logging into my supervisor, I will be able to verify that this works correctly. Also, because I don't see any certificate errors, I can make sure that my certificates were installed properly. And lastly, what I can also do is just check that everything's working fine. So I can switch over to my namespace. And also I can check that that persistent volume that I have attached to this VM has been mounted correctly. Now, there are a few more things I would like to mention for VM specifically. First of all, as you will see in the next demo, this is a service that we actually use to deploy our Kubernetes clusters because those are deployed on virtual machines. So we utilize VM service ourselves to achieve that. But there are also other things because we can, the virtual machines that we deploy with VM service, once they are deployed, are a virtual machine. There is no kind of different configuration. It's not a container running somewhere. It's a virtual machine. And that means that I'm able to utilize all of my tool sets that I would be using on regular virtual machines. So for example, you can use things like, for example, if you use HashiCorp Packer to build your images, you can use things like Ansible for configuration management and all of these things. So it's really important to keep in mind that while you can deploy these virtual machines in a different way and really efficiently and with a lot more kind of built-in automation natively, it's still a virtual machine. So it still behaves the same way. And now, the other thing I wanted to mention as well for virtual machines specifically is when I was talking about the VM classes that we assign, again, if you want to, you can create your custom one. So if you want to do specific hardware configurations, you can of course do that. When it comes to the images, you can build your own images as well. Because of time, we will not go through all of these demos, but if that's something that would be of interest, please drop us a message. I'm more than happy to come back and show you all of these things. So you can build images for example, Ubuntu. I can also do Windows VMs. In that case, we wouldn't be passing through Cloud Init, but we will be using sysprep to configure the virtual machine. So those are just a few notes. And now we can jump into the last section, and that is our VKS. So let me just open that demo. And in this last demo, I want to show you two things. So first of all, we will just go through the deployment of a Kubernetes cluster. And then I will specifically show you something else as well. So again, we're in the same environment. So let's continue. Perfect. So I'm going to create a Kubernetes cluster. Now, I often say this, if I wanted to be really specific and talk about how easy it is to deploy Kubernetes clusters on our platform, I would say that I can do it in 2 clicks because it's true. If you will see in this user interface, if I would click new cluster and click next here and finish, it would deploy a fully functional Kubernetes cluster using a default configuration. So what that means, as you can see on the right side, it creates a configuration that's basically using the latest version of the Kubernetes release that is available and some standard configuration options. So if you are testing this out, if this is something new, or you just need to test something on a Kubernetes cluster, this is a fantastic option because you can literally have a cluster ready in a few minutes. For the purposes of this demo, though, we will go through the custom configuration as well. So that's something I will select here. And now I can go through the configuration of my Kubernetes cluster. So again, I can give it a name. Now we use a concept of cluster class. So all of our VKS clusters are bootstrapped using Cluster API, which is a upstream project that we heavily contribute to, and is most commonly used for lifecycle of Kubernetes clusters, even between other kind of Kubernetes service offerings. With our cluster classes, we have recently switched to a slightly different model of deploying them. So every release of the service will come with its own cluster class that is assigned for that version. And this is really to make the management of these clusters slightly easier, and also to prevent any maybe unexpected changes that could happen on the system. So for example, if you would update your service version to a later version, we will not automatically trigger updates on all of the clusters that are already deployed. So that's really important to keep in mind. It's really to give you more control in the environment of the versionings. Then we come to the Kubernetes releases. So as I mentioned, we deploy these using this subscribe content library. So every time we release a new version, it will become available in the content library. Now, sometimes if we release a new version, like for example, this version 132, you have to have a matching version of the service installed. And this is how we are able to get you these releases so quickly. So we are fully aligned with upstream Kubernetes, and we are also very quickly releasing not only new versions of Kubernetes, but also new functionality. Every time we do, you can very simply just update the Kubernetes service. Because it's deployed as a supervised service, it would go through the same principle as we have covered when we deploy the user interface. So you would just add a new version and install the new version of the service. If we will have a few minutes left at the end, I can also show you a demo of that. So now I can select some networking settings. So the default for us is Antria, but we also do support Calico for the networking interface. And now I can define my control plane. So as I mentioned, a Kubernetes cluster would have a control plane. So here I'm defining the number of replicas for it. And again, using the concept of VM class. So this is where the individual concepts we went through link together, because as I mentioned, we use VM service in the background to deploy these. So the VM class, as we have defined before, would be used for the Kubernetes clusters as well. For the images and their operating system, for control plane, you can choose between Photon or Ubuntu. The control plane will always be Linux-based. If you want to, again, you can add additional volumes, or you can go ahead and configure your worker nodes. So in here, again, I can define the number of replicas, the sizing that I want to assign here. And then when it comes to images, as I mentioned, the control plane would be always Linux-based, but for worker nodes, we can also support Windows nodes. So you can build specific Windows-based images for your Kubernetes clusters if you do have that requirement. Now, again, I could assign another volume if I wanted to. What I also can do is I could go ahead and create additional node pools. So this is really useful if, for example, you want to have the same cluster, but you want to have different kind of workloads deployed on it. So maybe you have some supporting functions that could specifically run maybe on some smaller nodes. So you can add a node pool of maybe slightly smaller sized workers. Or for example, again, if you have any of those super cool AI ML workloads and you want to provide GPUs, you could create a worker node pool with VM class that has GPU backing to provide for those specific nodes. So again, we give you flexibility to tailor the Kubernetes clusters to your needs. And this is really important because as you can see, everything is not only self-service, but it's made to deploy many clusters, treat them as you need to, deploy them, destroy them, redeploy them, and size them properly. There's no waste of creating one massive cluster that everyone has access to. You can deploy as many clusters as you want and size them as you want to. So again, the manifest has been created for me. So I don't need to know how to do this. I can download it here and I can just click finish. Now, after my cluster is deployed, as you can see, that took 10 minutes to have it fully ready in that configuration. I can now log into this cluster and just check that my nodes that I have deployed are available and are ready. And because this is as I mentioned, a fully conformant Kubernetes cluster. So if you, for example, look at those custom resource definitions within this VKS cluster, you will see that all of your standard CRDs are there. What we can also do is look at some of the other objects that we have created for this cluster specifically. So still within the realm of our namespace, I can go and have a look at the load balancer. So every Kubernetes cluster, its control plane would be fronted by a load balancer. So that's there. And also, I can do some other things in this user interface. So for example, I can view its running YAML configuration. So the current state of the Kubernetes cluster. I can download the kube config file if I want to do that and just use that to connect to my cluster and to run my commands using that. Or I could, of course, delete it. But what we can also do is do some, let's call them day two operations directly from the user interface. So for example, a very good example is scaling. And this is something, again, because of the way this is built, it's supposed to be dynamic. It's supposed to be easily managed and easy for you to consume. So after the deployment, if you have decided that you want to add additional nodes to your node pools, or you want to change the VM class to give it different size, or you want to add additional volumes, you can always do that also as a day two operation directly from the user interface. Again, you can do all of this directly using the CLI as well. So now we have added additional volume and we can see that the volume has been created. Now, one important thing I wanted to mention here when it comes to the creation of these objects on the underlying infrastructure. As I mentioned before, we make sure that the underlying layer is always secure because that's what's hard coded into our ecosystem. It always has been. Security was always our top priority. So what we do here is very unique. For example, if I'm requesting resources within my VKS cluster, so within that Kubernetes cluster that I have just deployed, it never reaches directly to, as I mentioned, for example, vSAN or NSX to create those resources. What we do is something we call power virtualization. And what that allows us to do is we basically say that within the VKS cluster, we create a resource, but then we somehow mirror it on the supervisor layer, and then the supervisor can be the secure layer that goes off and requests those resources, and that sends it all back. And that ensures that, again, there's never any secrets with passwords floating around in the Kubernetes cluster, anything like that. It's very secure. So that's the deployment of our Kubernetes cluster. And now we do have 10 more minutes at the end, so I do want to keep that for the Q&A. But hopefully what we have seen in this demo, again, just to bring it all together, when we say that VCF is the platform to run containers, Kubernetes clusters, virtual machines on a single platform using a single API, this is what we mean, that everything is managed within the same ecosystem, which means single API, single management, the same tools, the same principles, and being extremely extensible. So that's the end of the demos. And as I said, we'll just leave this 10 minutes for questions if there are any left. Yeah. Welcome back, Michael.
Thanks so much, Katarina. That was fantastic. It's really exciting to see how far things have come, not only in the sense of like, VCF and vSphere and adopting the sort of supervisor model, but just Kubernetes in general. It's come such a long way from, where it began. Like I said, last time we had the call, I was at the Contributor Summit back in 2019, I want to say, in San Diego. And, at the time when I was doing Fusion and workstation things, we were writing some integrations with kubectl and, some of the container runtimes. And so I was, there helping out with that. And the goal at the time was like, make Kubernetes boring. Right. And that was great because it's like the idea was, it's hot and shiny and cool and, all the newness and whatnot. But like at the end of the day, you're just running workloads. It's just there's Linux threads, ultimately. And so, what containers gives you is that C groups, the isolation that you got there. And then virtual machines gives you that resource isolation. So not only you have your local or your logical isolation, but your actual physical isolation, which in our case is also logical isolation, So it's turtles all the way down, as we like to say, right?
It is. And I think it's really important to also mention that we know where the world is moving, right? Like if you look at any of the recent surveys that are coming from CNCF, we know that 80% of all new app development is happening in containers. We know that 90% of all of the companies that are included in the surveys are running Kubernetes. So it's definitely an important subject, and we all need to be able to, not only talk about, but also manage it. And it is important for all of us. But as you mentioned, that was always our goal. We want to make it simple. We want to use it, but at the same time, we want to give you what you've always had. We want to give you your same UIs you've used before and nice user interfaces, make it really simple, abstract the complexities away, but then also use the complexities on our side to be able to deliver all of this functionality really fast in this growing ecosystem.
And like while we're talking here, like I'm hoping folks use this opportunity to fill up the Q&A panel, answer some questions. I've got a couple that all ready to go here, but to your point about abstracting that complexity, it's like it's part of the declarative nature of part of the nature of the declarative model that Kubernetes employs, right? It's not like you walk through a UI and you click next a bunch of times and then you have a container deployed. Really, it's you define what your end state is supposed to be like, right? What your end goal is, what that finished state will look like, and then the system knows what to do to get it there, right? And so if you look at how, your application, maybe it's just a bunch of Python scripts, maybe it's the LAMP stack, whatever, you have your first packaging artifact inside the container. So that's everything that's specifically built for that application. But then you put that into a virtual machine, and we do that all using the declarative model. And so that way you're not like, deploying a VM, wiring it into a control plane, setting up your node pools and like doing all that stuff manually. That's just like baked in now. And I think that folks don't necessarily, unless you've really had to deal with Kubernetes the hard way, and I've been there, it's there's a lot more to it than but we take it for granted, right? Exactly. The hard way, It really is hard. Like I remember when Kelsey Hightower the first time he did his Kubernetes demo in I want to say 2015 in San Francisco. Kelsey was using VMware Fusion, for the record, just throwing it out there. And, it was a great demo because it actually all fell apart on him when he was in the middle of doing it. You can find the video on YouTube. It's a little tricky to find. It's not the easiest thing, but it was a hackathon meetup in San Francisco, and he gets up there and he goes through he'd already stood everything mostly up beforehand, but there was something funny that happened where, he's like, all right, we're going to do this demo. It's live. There be dragons. Let's go. Right. And he, fires up the VMs. His VMs start booting, but the nodes aren't registering back into the pool, and they're not calling home to the control plane. And he's like, what's going on? And so because the network changed inside of Fusion, like he did it on a wired network before, and then he moved over to the wireless network inside the hotel, and like stuff wasn't lining up. So he's like, crap, what do I do? What do I do? And so he reaches out to the audience. Hey, do you want me to push through, or do you want me to, are we going to just call it? And everyone's like, no, 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 push through. Demo gods, we got this. Let's go. And so he was like, all right, cool. Quickly SSHs into one of the VMs, re-registers the new IP addresses into the node pool. Okay, bam, boop, 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 stuff's popping up. The demo was a huge success, right? And it's that level of complexity that just has been so abstracted now, like literally the hard way, like he was doing it the hard way and using our hypervisor at the time to kind of make it happen. And all of those individual operations that need to happen in order to make the orchestration dance, so to speak, right? And so I think the value that we're really talking about here is, again, all that complexity has been abstracted. Things just sort of work. And so I'm not seeing a lot of go ahead.
There was one question I saw in the chat, specifically about yes, what is the future of NSX load balancer for VKS? Is there any plan to depreciate that for AVI? No, you can still use NSX advanced load balancer as well in the stack and integrate it. So just to answer that, I noticed that in the chat. So
awesome. Thanks for
cover
catching that. Yeah. I guess one question I'll have is and it's totally putting you on the fly here, on the spot. What kind of resources do we have available for folks? I guess there's probably two buckets. One who like I know Kubernetes, I don't care about the vSphere stuff. What do I need to know? And then there's I know the vSphere stuff and I'm not really a Kubernetes person. What do I need to know? Do we have resources available for those audiences?
Yes, we do on our website. There are resources, there are blogs. We also have a YouTube a kind of playlist on our VCF channel. So you can see all these different demos and different sections and pick what you are interested in.
So the Broadcom website is a little confusing for some folks.
It is.
They got a lot of products. We're one of many, right? What we'll do is, as a follow-up to the event here, is we'll capture a bunch of good resources, and then when we send out the link with the recording here, we'll include those as well. So I think that's about the long and short of it that we got. Unless you get something else, Katarina?
Nope, that's it. Right. Thank you very much for having me.
Julianne, if you want to come back out and send us away, obviously the big thing for me here is hearing back on the surveys. So, we hope you guys fill those out because it informs us as, not so much whether we're doing a great job. Obviously, we'd love to hear that we're doing a good job or not. But it's also to figure out, what do you guys want to hear? Like what's going to make your life better in this world that we can help share and bring in the experts from the division in to help, explain things further for y'all. So with that, thank you for having us. Julianne, send us away.
Yeah, that's pretty much it. Fill out the survey. Again, I know there was a little confusion about getting the link from part one. We sent it to everyone who's registered, so I will send it again. If you're not getting things from us, email memberservices@vmilk.com. It's possible that you have emails turned off, and that's why you're not getting emails from us. So just let us know if you need help, and we'll send that recording for part one and part two, and then the resources that Michael and Katarina mentioned. I'll also include those in the email. And then just keep an eye on your inbox. We have some more webcasts coming up. They're always on the events page, and then any of the recordings will be on the on-demand page. So just keep an eye out and go ahead and fill out that survey so we can get the content that you'd like to see. But thanks everyone for your time today and digging deep into this topic. I know it was a lot, so thanks for coming. Alrighty, we'll see you next time.